This integral belongs to the case 3 of trigonometric substitution. In the square root, you see that there is an x squared minus 1. So 1 is 1 square. So we let a equals to 1. So first of all, we have to let x equals to 1 times secant theta. Since we have to change the dx to d theta, we have to differentiate both sides. So dx is equals to the derivative of secant is secant times tangent. So secant theta times tangent theta d theta, and then we will replace the dx with this. So the dx is gone, will be gone, it's not gone now, and then the x to the fourth in the denominator, so the x to the fourth is equals to secant to the fourth power theta. What about the square root? X squared minus 1, so that is equal to secant square minus 1. So secant minus 1 is tangent square. Do you see that in red? So that is equals to tangent square theta, which is equals to tangent theta. So every component in the given integral is now in theta. So we have integral, the square root becomes tangent theta, the denominator is secant to the fourth power theta, and then the dx is secant tangent and then d theta. So let's simplify this. The secant to the fourth, we reduce 1 power, and then the tangent will be multiplied together. So you have a tangent square theta divided by secant to the third theta d theta. And then the next thing that we are going to do is we are going to split up the tangent and the secant. So we are going to do this tangent square times 1 over secant to the third and then d theta. So for the tangent square, I am going to change the tangent square to sine divided by cosine. So sine divided by cosine, of course they are both square. And then the secant is 1 divided by cosine, right? So if you have a 1 divided by 1 over cosine to the third power, so that is just equals to cosine to the third power. So this is cosine to the third power theta d theta. And then the square and the third power, we can reduce that one step further. So we have a sine square theta times cosine theta d theta. The next step that you will want to use a u substitution, but should I let the u be a cosine or sine? So let's try. So let's say I let u equals to cosine, then du is equals to negative sine, right? So negative sine theta d theta. So this will reduce a sine for me, but after that you still have a sine times u. So in other words, that is not going to work. So what else can we do? How about this? Let's try let u equals to sine of theta. Then du is cosine d theta, then 1 divided by cosine theta du is equals to d theta. So that is going to get rid of the cosine for me, right? So let's rewrite this. So first of all, we have the integral of u squared, right? And then the cosine is still there, cosine theta. And then we do the change of variable. So the d theta is now 1 divided by cosine theta du. As you can see, the cosine will be cancelled, and then we can just integrate the u squared, right? So that is 1 over 3 u to the third. And then what is u? U is sine, so that is 1 over 3 sine to the third power theta plus c. Are we done? No, we are not done at all, because the given integral is in dx and you stop at d theta. To go from theta back to x, you will have to use right triangle trigonometry. So let's do that in a different color. So right triangle trigonometry. So this is my right angle 90 degree and then theta. So how do I start? You have to go back to the very first line you wrote. X is equals to, this is what you wrote, x is equals to 1 times secant theta, right? That is the very first line you wrote. And then x divided by 1 is equals to secant theta. Secant is 1 over cosine, so x over 1 is 1 divided by cosine theta. And then you can take the reciprocal on both sides. Cosine theta is equals to 1 divided by x. And then cosine, well, Do you still remember this? SOHCAHTOA, C-A-H. So the A is adjacent, and then the H is hypotenuse, right? So adjacent is equals to 1, hypotenuse is equals to x. What about the opposite? So to figure out what the opposite is, so here is what you can do. So you draw this, and then using the Pythagorean theorem, we have a squared plus b squared equals to c squared. And then the b is equals to c squared minus a squared, right? And then you take the square root of that. And then in here, the b is equal to x squared minus 1. So this is the square root of x squared minus 1, c squared minus a squared. So now you have the right triangle trigonometry, and then according to that, so we have SOHCAHTOA, S-O-H, so that is opposite, divided by hypotenuse. Opposite is the square root x squared minus 1, hypotenuse is x, so that's all you need. And then all you have to do is you put this back to the green, and then overall, the final answer is 1/3 sine, so that will be a third power, right? Then you have to raise this whole thing to the third power, the square root of x squared minus 1 divided by x, and then you add c to it. So that is the final answer to the first integral. Now, we just explained what? We just explained the third case, x squared minus a squared, right? So I want to show you another problem, and then I will end this video. So the other problem that I want to show you is what if I have this? So what if, let's do this in a different color. So what if I have this? So what if I have the integral of x divided by x squared minus 7, and then dx. This one you can use this x squared minus a squared. You can do this, so x squared. So since you want to square that, you can put the 7 into square root of 7. Because you square that, you get the 7. So you have a equals to square root of 7. Should I stick with this, or I could use another method? So in this problem, the yellow problem I gave you, you do not need to use a trigonometric substitution. This one you can just use u substitution. So you let u equals to x squared minus 7. The reason I do this is once you take the derivative, you have a 2x, and the x is going to get rid of the x on top. So 1 divided by 2x du, that is equals to dx. So we have integral x and then u to the 1/2, and then 1 divided by 2x du, so that 2x will be cancelled. Then you have 1/2, and then integral u to the negative 1/2 du, so that is 1/2. This is a 2, still have a 1/2 in front, and then you add c to it. So overall, you have the square root of x squared minus 7 plus c. So this one is just a couple lines. You don't even need to use trigonometric substitution. But when you turn to the section of a book where they introduced trigonometric substitution, trust me, the person who wrote this problem will do the best job to make sure that you cannot use other methods to handle it. Or they will just say you have to use trigonometric substitution, otherwise you don't get any credits. All right, so be careful with that. So that is the end of this video. If you think I picked the best problem for discussion and my explanation is clear, give me a like, let me know in the comment below, share the video for me, subscribe to my channel. Appreciate your help. See you all in the next integral. Signing out for now.